c'est parti.
Ouais, je pense que normalement ça démarre dans 5 minutes, on aura un peu de retard, ils vont voir la salle vide,
Voilà.
c'est pas bien grave.
De toute façon, il y avait pas, enfin hier il y avait, je crois, jusque 1 à 2 personnes en attente au niveau de YouTube, c'est tout.
Ok. Ouais, sinon, j'ai enregistré quand même le truc.
Ouais.
Donc ça,
là, il enregistre aussi, du coup?
Oui, ça, il enregistre. On ne sait pas ce qu'on va faire avec.
D'accord, très bien.
Ça enregistre. Et puis sinon, il y a un autre truc, ce qui va se passer, c'est qu'il y a c'est un peu long, en fait, la conversion du truc à la fin.
Ah oui, ça, c'est sûr.
Et j'ai une autre visio qui démarre.
Juste après?
Ouais, bon, il y a 10 minutes, 15 minutes, mais je trouvais hier, c'était un peu long. En fait,
ouais.
Mais bon,
ouais, bah oui, ça.
On va faire avec.
Ok, donc là, normalement, c'est bon. La
Voilà.
diffusion est lancée. Même les gens sur YouTube doivent.
Voilà. Et donc, moi, j'ai ouvert mon truc.
Là, je vous laisse régler la caméra en fonction de l'intervenant.
Voilà. Donc, à chaque fois, je vais aller ici. Je vais demander à l'intervenant de s'asseoir où il veut. Et puis, s'il veut se mettre devant.
Et puis, ouais, régler la caméra.
Donc, je vais baisser ça. Et puis, il y a le pointeur. Et puis, c'est bon.
Ok. Parfait. Merci beaucoup. Hein.
De rien. J'ai eu un petit échange avec Marlène ce matin. Oui. Je me demandais si elle allait faire le truc en français en anglais. Ah oui, en anglais si c'est possible. Ouais, je sais ce que je l'ai dit. Oui, que vous allez. On va essayer de faire. Moi, le chat, c'est en français, j'ai peut-être échangé. Mais de toute façon, c'était pas en anglais. Voilà. Je l'ai dit que tu vas parler. Je pense que peut-être John, il va nous dire directement. Ouais, oui. Très bien. Okay, so it's your presentation. Okay.
Okay.
Maybe it will be a little late. I don't know.
People tend to be, yes. On the first presentation after the first buffet. That was a good restaurant last night. And I was with, what's his name? The Israeli guy.
The name of the restaurant?
No, I was talking with that Israeli guy. It's called Sharon.
Sharon. Okay.
He's an interesting guy.
Okay. You will present today or tomorrow? I don't know.
I haven't been to his presentation.
Okay.
But seeing as there are two parallel, one doesn't see everything. No, I trust Serge, you're not going to embarrass me.
No, sure. I will just say that everybody knows you.
Well, I don't know whether they do. This audience is quite different from the usual audiences. So are you going to FUR?
Sorry?
Are you going to FUR in Ghent?
I think I will do it. You also?
Yeah. I've been to all except one, I think.
I think we will again present the theory with we for the last time. Because we work a lot with the theory of we. And I think now it's there are two papers. There's a paper with we, and we has his own paper also. And I think it's good enough, but it's difficult.
I've been to all FUR. I went to the very first FUR, which was in Norway. I remember arriving on a boat from the UK. There were boats from Newcastle to Bergen. Or
it was in the 90s? It was in the 90s or in the 80s?
89. I don't know.
80s. Yeah.
I'm not going to wear this while I talk.
I don't know who organized FUR. I don't know who organized FUR in Ghent.
I should know the name. I'll tell you later. What does PANO stand for? In the title of this conference. What does PANO stand for?
Nouveau risque par placement. placement, when you share, it's a portfolio, when you choose when you choose a portfolio. Placement.
Okay.
Placement. I don't remember. I know that this is nouveau.
Okay.
I don't know.
You don't know.
Assurance. So it's a portfolio, assurance.
Assurance.
Nouveau risque.
You have to stop smoking.
Chef Serge, c'est Serge.
Where is François? Where is François?
No, because François has to be in Paris today. Okay. He has to present an official presentation. It was not possible. Okay. Hello everybody. So we start. So we'll have the pleasure to see the presentation of John Hay. I think maybe most of you already know John. John Hay is one of the first experimental economists in Europe. I think you have a book, Experiments in Economics. It was just 30 years ago, one of the first books in experimental economics. John has done a lot of experiments, a lot of original experiments. I remember John showing to us a urn with balls with variable speed. They can stop. You can compute the probability, or the speed can increase, and you go to total ambiguity. And so I think you represent a beautiful experiment. There's a famous paper I have worked on it. Everybody worked on a paper in Econometrica with Orm, where John compare all the theories, expected utility, prospect theory, rank-dependent expected utility. There is a lot of work. You can see the work of John on the web, and now you can it's yours to speak.
Thank you, Serge. Thank you, the organizers. That's Constantin, I don't know where he's here, and Francois. Thank you for inviting us to this conference. I must start by apologizing for the fact that the paper I'm going to present is different from the paper on the site. The original paper on the site is co-authored with Li Wei Lin, who's sitting down here, and is, I think, an interesting paper. It's on testing theories and comparing different theories in a particular context. The theory journals, econometric in particular, are full of theory papers, lots of axioms, lots of derivations, which I don't understand, and we were very keen to test them. So that paper is still available. And if you've got any comments about this, about self-control and temptation. It's a story about if you're choosing a menu and then choosing from the menu how you do this choice. So you choose a restaurant to go to in the evening, like Libertin, and then when you get to Libertin, you choose an item from the menu. And the choice of the restaurant determines your choice when you're there. So that's what that paper is all about. And if you've got any comments on that, we'd be very grateful. But this is different because I realize that the audience here aren't really interested in testing theories in the way we are. This is about financial institutions, which I think is much closer to your heart. So this paper here compares experimentally two market institutions. So it's much more in line with the objectives of this conference. It's a joint paper with Enrique Carboni, who's at the University of Campania, and Tibor Neugebauer, who's Professor of Finance at the University of Luxembourg. So let me just go, without further ado, these are the motivations. We want to compare two different financial institutions and compare them in terms of their efficiency. So we compare a market in which consumption claims are traded through a long-lived asset, an asset market, with a market in which agents can directly trade consumption trades period by period. So we've got two different market institutions. We want to compare their efficiency. So the first one, the asset market. In this asset market, there is an asset which sole purpose is to smooth consumption through time. The asset pays a dividend. So if you want, you can buy the asset, hold on to it and earn the dividend every period, or you can trade it depending upon the price of it, and therefore vary the amount of cash you got at the end of the period, and hence vary your consumption at the end of the period. I must admit, intuitively, an asset market seems a very clumsy way of transferring money from today till tomorrow, but that's the story in that asset market. My feeling is a more obvious and more direct way is to have a financial arrangement where you can actually trade money today for money tomorrow. And we call that, well, we have great arguments about what kind of thing to call it. But that's the key research question we're asking. Which of the two markets is more efficient? Perhaps you have already intuitive ideas of which is most efficient. I would personally think where you could trade directly is more efficient, but let's just see what it says. So these are two general equilibrium models, and these are the foundations. Lucas is the key paper on this, who has a long-lived asset. The asset doesn't perish. It remains, if you buy it and keep it, it stays there forever and pays a dividend every period. It doesn't perish at all. Cash, however, in the story is perishable. So cash at the end of a period just disappears unless you consume it. The basic story is you consume the cash you have at the end of the period. And to make this model work, to make trading possible, we need incomes to vary from period to period. Otherwise, people don't want to trade. And the ultimate objective of the story is to evolve a strategy where you smooth your consumption through time. Your income is random. It varies from period to period. You use the asset to trade, to move money from one period to the next. And the ultimate objective is to get a consumption path that is smooth. And the reason for that is that the utility function is concave. So consumption smoothing is the ultimate objective of the story, okay? And we compare that, we've called it here a credit market. We used to call it a forward market, but it's a market in which cash is perishable, unless you can, well, you can consume it at the end of the period, but you can trade cash this period for cash tomorrow in this, what we call the credit market. Is that correct terminology? I prefer forward market. You can trade money today for money tomorrow. I would call that a forward market, but we're calling it a credit market, okay? And once again, consumption smoothing is the ultimate objective. Okay, what do we find? Well, I don't know whether these results are surprising. We observe consumption smoothing in both contexts. People manage to do that, but the credit market is more efficient at doing it than the asset market, which doesn't surprise me. And interestingly, we see bubbles in the asset market. We see bubbles where the price rises way above the fundamental and then crashes down. And in the credit market, trade takes place at equilibrium, of the equilibrium prices. Do you want to talk about literature? Okay. This is obligatory in the presentation. Lucas is the key reference, and a experimental study of that is by Crockett et al. In the Review of Economic Studies, and there are other journals. So let's look at this experiment by Crockett et al., which tests the Lucas model. So in this story here, trading is over an infinite number of periods. Now that creates an immediate problem in the laboratory. You're not allowed to keep your subjects in the laboratory for an infinite amount of time. Apparently the rules don't let us do that. So we have to employ an experimental device to simulate an infinite number of periods. Now in the original Crockett model, in order to induce trade, there were two types of traders, and the different types of traders receive different income streams, and therefore they want to trade. Okay? They start originally with different amounts of the asset, and so they might want to accumulate the asset or sell the asset in order to achieve consumption smoothing. And as I said already, the assets pay a dividend each period. And crucially, the income of each subject is random from period to period. And to induce consumption smoothing, the utility function is a concave function of the cash at the end of the period, which is the thing which their subjects are paid on. And you can vary end of period tokens by buying and selling the asset. So if you feel as though you've got too little, let's say it this way, suppose your income in a particular period is too low and you want to increase it, you can sell any asset you got and therefore increase the number of tokens. If you've got too many, if your consumption at the beginning, if your income at the beginning of the period is too high and you want to reduce it, you can buy the asset. So you can use the asset to vary your end of period incomes. Okay. And as I've said already, the objective is to consumption smooth. Let's talk about equilibrium. We're searching to see if there is equilibrium. And in the equilibrium, these are obviously Nash equilibrium. Both types of agents, consumption smooth. I'm going to give you a little story about equilibrium prices. Well, perhaps that's intuitively obvious. The equilibrium asset price is the discounted value of future dividends. So if you hold an asset, you get a dividend every period. So the equilibrium price of the asset is just the expected discounted value of the dividend income every period. Okay? So that's the equilibrium price of the asset. We had a discount factor of 5/6, which we implemented in the laboratory by having a random stopping rule. So any particular market sequence went for a random number of periods and continued at the end of any one period with probability 5/6. That induces a discount factor of 5/6. In the experiment, the per period dividend was 2. So we can work out the equilibrium price of the asset. It's simply the discounted value of 2 every period forever. And in our particular, it was 10. If you work out that sum there, the equilibrium asset price is 10. So we're looking to see if the asset market converges to an equilibrium price of 10. Right. Crockett et al. Was an earlier paper, and we have 2 major innovations with respect to that. They had subjects with different incomes every period, which oscillated. So they were high, low, high, low, high, low. They oscillated through time. We moved to a 3-period cyclical income. So you got a high, medium, low, and you want to transform those through asset sales to get consumption smooth. We had different parameters, obviously, and we introduced a new treatment, which is this credit market. That's crucial to our story. We want to see if the credit market is better. Now, I was saying earlier, in this original story, the payment function was a concave function of end of period cash holdings. Okay. Now, instead of having, well, we had 2 payment functions, one a concave, nice smooth concave function, another one a step function. So on this picture here, I don't know if you can see this picture here. This is the original concave function. And this one was a new one we introduced, a step function. And it's a step function. You notice there's a step at a particular value. I'm going to ask the question, why does it have a step at 79? This was a clear signal to our subjects that in equilibrium, they should try and consume 79 every period. So if they consume more than 79, they get a payment of £1. If they consume less than 79, they got a payment of £0. The referees weren't particularly keen on that, but I like it. It's a step function, okay? Right, let's talk about how we set this experiment up. We set up the exogenous items in this cyclical asset market. Can you read that? Okay. So, as I say, it's cyclical. So, periods 1, 4, 7, and so on, there's one kind of income. In periods 2, 5, 8, and so on, there's another income. And notice there are different types of subject. There are type 1 subjects, type 2 subjects, and type 3 subjects. And they get different incomes every period. It oscillates. So type 1 subjects get income of 109, 53, 67, and it cycles through time. Type 2 subjects 49, 113, 45. Type 3 subjects 59, 51, 105, in order to induce them to consumption smooth. They start with consumptions that are different. They start with holdings of the asset, and you'll notice that they have different asset holdings. Type 1 have 0, type 2 have 5, and type 3 have 5. So they have different asset holdings to start with, different income streams through time. That's the exogenous item. And now here is a picture of equilibrium trade in the asset market. Now this is quite difficult to read. So they start, type 1 start with 0 assets to get this oscillating income 109, 59, sorry, can't read my own slides. Income 109, 53, 67 are type 1 incomes. Those are the exogenous items. And this is what happens when they trade in equilibrium. So type 1 subjects start with 0 of the asset, and they have a high income in the first period. So what they need to do is buy the asset. So they buy 3 units of the asset in the first periods, and they buy 3 in the first period. They sell 2 of them in the second, and they sell 1 in the third. So they end up back where they started. So that's the equilibrium configuration. And they should be moving their asset holdings and therefore their consumption in this particular. Some of you are looking worried. Are there any questions about this? Because this is very important. Yes.
Do the subjects know this cyclicity in the beginning of the experiment?
Do they know what, sorry?
They
know, they're told the oscillating incomes, and they're told what they're going to be throughout the experiment. Yeah, they know those. There's no risk there at all. But obviously it's oscillating, so it's in a sense risky. Any other questions? Okay, right. And what would happen if in equilibrium, they would all trade in such a way that their end of period consumption, every period, was 79. There's 79 here, 79 there, and 79 there. They would all trade to have an income, sorry, a tokens of 79 at the end of every period. And with that consumption, that conversion function, they would therefore get a payment of £1 every period that the market continued for. And if they didn't trade in equilibrium, they'd get less than £1. Okay, let's look at the credit market, which I think is an awful lot simpler. These are the exogenous items. Once again, we've got oscillation. So periods 1, 4, and 7, type 1 subjects get an income of 109 and 2, 5, 8, they get an income of 53. These oscillate through time. And again, in order to get consumption smooth, they should trade. But if it's a credit market, they trade income today for income tomorrow. So these are the equilibrium trades in the credit market, and the equilibrium price in the credit market is 1 over beta, the discount factor. You're trading today for money tomorrow. The discount factor is 5 over 6. In our experiment, the probability that there would be a next period is 5 over 6. So the equilibrium price is the inverse of that, 1 over 5 over 6, which is 1.2. That's the equilibrium price in the credit market. So 1 unit of money today trades for 1.2 units of money tomorrow in equilibrium, because the probability of tomorrow happening is only 5/6, not 1/6, not 1. So that's the equilibrium in the credit market. And in the equilibrium in the credit market, everybody consumes at the end of every period 79. So they get consumption smoothing. They all get an income of £1 every period if they're trading in equilibrium.
I'm sorry, could you repeat the explanation for 1.2? Is the price of the equilibrium of today or the equilibrium price
tomorrow? Tomorrow. Because the probability of tomorrow happening is only 5 over 6. So if you want to trade money today for money tomorrow, and you're risk neutral, I must admit, I'm assuming that 1 unit tomorrow you might not get the money back because tomorrow might not happen. And the probability of tomorrow not happening is 1 over 6. The probability of it happening is 5 over 6. Okay. Okay, so that's the equilibrium in the credit market, which I think is much easier. And once again, if they're behaving optimally, if the market is at equilibrium, perhaps I should put that, then everybody would get £1 every period. Okay, now we need to implement this experiment in the lab, and the problems are the discount factor. Well, I've already explained, we can't keep people in the lab for an infinite amount of time. It's not legal. So we have a rat. So what happened at the end of every period of trading, we got a subject to roll a die on the table. And if it came up as 6, that particular sequence of trades finished. And if it came up with any other number, it continued. Now you can see that that's slightly problematical in the lab, because it could be the case that you never got a 6, that people kept throwing less than a 6. So in principle, the experiment can continue forever. But the probability very low. It never actually happened. We did put a time limit. We said if the experiment's been going for 2.5 hours and the 6 hasn't appeared, we're going to stop it anyhow, and we'll continue next week. So that's one way of implementing that. That's what we did. Okay. And what we do to operate pricing is use a double auction. Now the next screen is the screen we use for trading. This is very familiar, Z-tree. How many of you use a Z-tree? Well, okay. How many of you do experiments? Very few of you do experiments. It's a way of getting real data rather than the data from surveys, okay? So this Z-tree is a very famous software in experimental economics. It's very easy to program. I don't like the colors. I think gray and orange are mucky. So this was the trading screen. So what happened is if people wanted to buy the asset, they would put what they wanted to buy in this box here. And they would say the price at which they're willing to buy and the units they want to buy in this box here, and then click on there. And if you want to sell, we'd put the units to sell here, the selling price in there, and click. And any active trade or offers and bids and asks would be put up here in this top branch up there. So if I said I would like to buy 5 units at a price of 10, I would click in 10 in here, 5 in here, click on this button here, and my would appear up there. So people could see the bids and asks, and they could accept bids and asks at any point. So if somebody put up a bid or an ask and somebody accepted that bid or an ask, a trade would take place, and the trade would be recorded in this screen here. So that's the normal mechanism for trading in a double auction. Yeah?
People are writing in press, I work in a brokerage house, and I have a different opinion on that. So probably the reason in France, when you start to feel the bid and an ask, when you go to the market, you have already bid and asked
Yeah.
which aren't filled. So I am wondering if the first one is selling,
Yeah.
what will do the second one? So there is any sequence? Do they see the sequence of the bid and the sequence of the ask?
Exactly.
Because I worked on a market which was very liquid. So it was, if you had a lot of bids and few asks, so they do not trade anymore.
Yeah. Well, the actual sequence is crucial.
Sorry, they trade a lot. If you have a lot of ask and very few bids, in reality, the trading begins to disappear.
Yeah.
So it's not, there is an importance of the sequence of the bid and the ask, which are filled here. Do they see or the sequence? There is a first, I don't know, the first person who filled the first, afterwards the second, and so on. Or they have a bid and an ask that is already filled.
No, they see it as it goes. As bids are placed, they're put up in that top box. If asks are placed, they're put up there. But we don't control the sequence of them. But they all can see the sequence. And I think your point is seeing the sequence influences what they do. I totally agree. But we didn't want to interfere with that. Okay, so they could see the sequence. And I would imagine if I wanted to buy and I saw lots of offers to sell, I would offer slightly more. You know, the actual posted bids and asks will influence my decision, definitely.
And I have a second question. If I correctly understood, they all begin with no asset.
No, subject type 1 start with 0, the other two start with 5.
Sorry.
So yeah, you're right. So some subjects start with low assets, some with high assets, and they trade them. Yeah. Otherwise, you wouldn't get any trading. If you all started with the same or with 0, you wouldn't get any trading.
You should let them sell you short.
No, we don't let them. We don't let them sell. I mean, the serious problem is that they could lose lots of money. And you can't take money off subjects of experiments. It's not allowed.
Okay.
But we don't. Has anybody tried? Have you tried that?
Sell short? No.
No. Okay. Right. What's happened here? We've got advertisement. How do we get rid of this advertisement on the right hand side?
I don't know how. I will call Dimitri.
Oh, can I press on this X? Doesn't work. Okay, it'll perhaps disappear. So that's the screen, the trading screen in the asset market. People post bids and asks, they accept bids and asks, and trade takes place. Okay? In the credit market, which I think is a lot simpler, it's almost the same, except the way we let them post bids and asks, they vary. We'd either let them post, I can't read up there, the amount of current tokens they want in exchange for tokens next period, or they can post a price and the number of units they want to buy. I must admit, I find the first more intuitive. I've got some money, I've got 10 units of money, and I want to swap them for 13 tomorrow. Okay, it seems much more obvious to put 10 and 13 in the boxes rather than work out an implicit price. There is an implicit price of 1.3, and my intuition is that it's better to put 10 and 13 rather than 10 and 1.3. So that's the trading screen, exactly the same scenario there. Posted bids and asks were put in this middle top box, and people could accept bids and asks at any point from the person. So as trading took place, this picture would gradually fill up with the trades that they had themselves conducted and their present position in terms of asset holding or credit holding. Okay. And we gave them various screens to aid their decision making. So let's just talk about the experimental procedures for those who like it. We read the instructions aloud, and then, because it's quite complicated, the trading process, we had a video recorded of how they should do the trading. So I recorded my dulcet tones on a video, and they could watch me trading, and they could see the trading process. Okay, and crucially, we let them practice for a long time, and that was really important. They could practice trading, which obviously the practice didn't affect their payout. Each period of real trading lasted 3 minutes. I mean, there might be end effects. I'm not quite sure. Do you observe end effects? If you give them a certain period of time, they trade at the beginning, people might wait right to the end to make a quick sale. So we fixed 3 minutes down. And we have 3 types of subjects, type 1, type 2, type 3. And we have 4 subjects of each type. So we had 12 traders in total in this experiment. And as I said, we didn't allow short sales. And this is our way of implementing the discounting rate. We've told that already. Oh, well, people like debriefings. I don't like debriefings. We ask them questions at the end. What gender are you? Well, they probably don't lie too much there. But other things like their attitude to risk, I'm very suspicious of these kind of things. But we added those in. And you'll be glad to know they have very little effect on the results. Okay, let's look at the results.
Is it a physical die that they are rolling?
Yeah.
Why did you choose this rather than a random number generator?
Well, interestingly, when you get the computer to generate random numbers, subjects seem to accept that. But I must admit, if I was a subject, I would know that the random number generator is fixed. You seed a random number generator. So I don't like computer generated. So we thought a physical, actual rolling, they could see the person rolling a die, and they could see the person shouting out the number on the die. So that's what we did. It was physical. Yeah.
So is it, each session is not a one market, is it?
Sorry?
Each session, is it one market?
No, we repeated markets. Okay, I should have given more detail. We kept on repeating markets until at least an hour had elapsed, but less than 2.5 hours.
And then the end of the world was for all of them.
Yeah.
So you were risking a lot to get too short or too long sessions, right?
We had some very short sessions which lasted 1 or 2 periods, and some very long ones which lasted 40 periods or so. But that was entirely random. As I say, we said the experiment will last a minimum of an hour and a maximum of 2.5 hours. You know, so the first 6 rolled after an hour, it stopped. But if you never got a 6 after 2.5 hours, we told them to go away and come back the next day. But it never happened. But that was in the instructions.
I have a question on that previous slide. So each period lasts 3 minutes. So that's a long period. That's a long period for people to make decisions. So assume that they inserted some numbers. Okay, can they divide them or not?
No.
No. Okay. So
I mean, they could, if they want to improve their bid or improve their offer, they could put in another bid or an offer, but they can't withdraw them, and they couldn't. We couldn't reduce them.
So they can place several. They can place several bids and asks within the same period.
Yeah.
And okay. So,
exactly.
So you don't, and you really don't see any effects towards the end of the period.
We didn't, but we haven't looked closely.
Okay.
You think we should look closely?
Maybe.
Yeah.
I do this experiment in class for a competitive market, and there is very, very, very strong, when subjects understand what is happening, there is very, very strong effect towards playing strategically towards the end.
Okay. Well, we'll look at the data and see if that was happening. But it struck me most of the trades were early on. But you're right, we should look at that. Good point. Okay. So we used the exec lab, which no longer exists because of COVID. The exec lab has existed since 1989, but now the university has decided to close it. We had 192 subjects, 16 sessions each with 12 subjects, and they earned on average £17. And they were in the lab on average for about an hour and a half. So this wasn't bad earnings. And that's a little, can we not get rid of that thing?
If you click on the cross.
Well, I've tried that. If we click on with, sorry?
The mouse.
On the mouse. Ah, good.
No, on the cross. Okay, yes.
Okay, but remember, I'm getting old. Okay. So that was our setup. We have 4 different sessions of each. We've got 4 treatments: an asset market, credit market, and there's two different payoff functions, a concave payoff function and a binary one. So we had a total of 16 different treatments, if you like, but just 16 different sessions of 4 different treatments. Okay. Now this was the consumption smoothing. The average payoff, if they're behaving optimally, is £1. And this gives you a figure of the actual average payment. And those asterisks, I think they indicate significance from 0, which is a bit stupid, because the prediction is they're getting £1. So these are different markets. The first row is step payment function in the asset market. Step with the credit market 86, concave with the asset 45, concave with the credit 73. And you'll see the credit market has a higher average payoff than the asset market. This is what we expect. So these are the results. So looking at consumption smoothing, people manage to consume consumption smooth in both the treatments, both the asset and the credit, but it works better in the credit market. They were better able to smooth their consumption in the credit market, which doesn't surprise me. Some data to figure that. Okay, I've got some graphs in a minute. But with the concave payoff function, it was sort of similar. Consumption smoothing was observed better in the credit market than the asset market, for both the concave function and the step function.
Apologies. What is consumption smoothing? You allow them to have a candy every round?
No.
What consumption?
Okay, I should be clear that their payoff depends upon their token holding at the end of a period. So they start with some tokens at the beginning, they trade the asset or whatever, and they end up with some tokens at the end of the period. And their payment depends upon their end of period tokens holding. And through these conversion scales, it implied an amount of money. And consumption smoothing says they should try and get to 79 units at the end of every period. So we pay them in real money depending upon their token holding at the end of every period. So basically the story is they start with some undesirable levels of token and they want to trade towards desirable levels.
So just to reiterate, you induce risk aversion by giving them a concave payoff.
Yeah.
You induce a consumption by awarding them money every round based on how many tokens they have in this round.
Yeah, at the end.
And you call it consumption, but it's not exactly consumption. You're just implicitly assuming that because you know the optimal consumption, that they should consume proportional to the wealth. So the more wealth, the more consumption they have.
Well, the more tokens they end at the end of every period, the more money they get.
Yeah.
And we assume their utility function depends upon the payment, the money, not wealth, because we don't know their initial wealth. So we pay them according to the amount of tokens they have at the end of every period, and we pay them over all sequences of the experiment. So what we mean by consumption smoothing is really payment smoothing. Yeah. Okay. Now this is a graph about. So this is beautiful colors. Don't you know beautiful colors? So these are periods, and each of these is a market sequence. So the blue sequence lasted just about 18 periods. The rather poofy pink lasted for almost 30 periods. And these were the average payoffs in the step asset sessions. As I say, if they're behaving optimally, they should act in such a way that they end up at £1. So this is what the equilibrium suggests, £1. And this is what they would do if they didn't trade at all. So the bottom line is what they would get paid if they didn't trade at all. This top line here is what they would get paid if they traded in equilibrium. And we're not quite in equilibrium, but it's clear that they're well above disequilibrium, if you like, and approaching equilibrium. I agree it's not perfectly in equilibrium. That's in the step asset sessions. Here, the concave asset session. I think the step function is rather more obvious. We're basically telling them there's a step at 79, and basically we're telling them they should consume 79 at the end of every period, because they get £1 if they consume more than 79 and nothing if they get less. So it's a very strong hint. So in the step function, I think it's rather more obvious. This is the concave function. Once again, it's way below the £1, but it's generally above the sort of no trading line there. So it's not too bad, but that's the asset market. Let's look at well, we're now calling it a forward market. We've called it a credit market, the other market. You haven't told me what you want me to call it. Is it a credit market or is it a forward market? Trading money today for money tomorrow. Come on, you're finance experts. What's the official terminology? Yeah?
There is no possibility to have negative payoff because you.
No. Well, let's just go back to those payoff functions. I mean, it might go back for a while.
In the experiment, so even if the way you have zero.
I think on the concave function, it does become negative. Sorry, there we are. It does become negative. It could become negative. It could get negative payoffs with this concave function, which goes, here's -1. This is 0 here. So they could get negative payments.
But not in the experiment.
Yeah, well, they could in a particular period. When averaged over all periods, they didn't. No one got negative payments, but they could have done, but they didn't.
Oh.
They must have been quite clever. Let's go back to how we do for time. Well, we're not running out of time. So this is what I end up. This is consumption smoothing in the forward or credit market, whatever you want to call it. And you'll see the figures are much closer to the optimal, which is 1 up here, way above the no trade situation down there. So in the credit market or forward market, they do much better in approaching the optimal. These are consumption smooth, less so with the concave function, but still way above the no trade equilibrium. So they're trading towards equilibrium. They're obviously not getting there, because if they got there, they would be on this one line here. These are average prices. Remember that, well, perhaps you don't remember, the equilibrium price in the asset market is 10. The equilibrium price in the credit or forward market is 1.2. But these tell you the average prices in the various markets. So the equilibrium price is there. Interestingly, in the asset market, we saw bubbles. I'm going to show you some bubbles in a moment. So the average prices you see in the credit market, where the equilibrium is 1.2, that's the equilibrium 1.2, and they're not too far from it. There's the credit market again, just a little bit above the equilibrium price. So the average prices are close-ish to equilibrium, but not in the asset market. You know, the asset market here is way above equilibrium, and here down there. Sorry, here is below equilibrium. I've actually got some pictures. You can see these bubbles. Okay, this is an interesting session. Each of these is a particular session. And you'll see that there's a bubble which sort of breaks, doesn't completely break on the green one. And the other ones are sort of close-ish to the equilibrium price of 10, which is down there. But this one was bizarre. I don't really understand why the price went so high. I mean, I suppose people were buying the asset in the hope of selling it later. But I know it isn't. And that's even more striking. These are mean prices. So the mean price, this is the asset market, goes really high. Those dots, I'm not quite sure what the dots mean. So what this is a clear bubble that bursts. Down here, we seem to have reasonable prices. So mean prices show bubbles happening. These are the forward market, and the equilibrium is 1.2. My co-authors insisted on having a very large scale here. So it looks as though there's big dispersion, but in fact, the dispersion is not all that big. And here's the concave. Again, the equilibrium is 1.2 down here. There seems less evidence there of bubble behavior. I'm destroying your clicker. So what do we conclude from this main experiment? The credit market performs better in terms of equilibrium predictions than the asset market, which doesn't really surprise me. And bubbles occur in some market sessions. I don't quite understand why we get this bubble.
So it could be that the bubble is a mistake that one student made and traded at the wrong price, or is this bubble aggregate many transactions?
Well, these are average prices.
So the average was very high. So
Yeah.
it's aggregate many transactions.
Yeah. So there are a lot of people trading way out of equilibrium, which I don't really understand in this experiment.
So maybe when you debrief next time, you can tell them what was going on and ask them if you traded far from the theoretical price, why did you do it?
So we should tell them the equilibrium price.
And when it's all over, at the debriefing,
When it's all over. And then ask them why they did that.
yes, maybe
Okay.
they will give you an interesting answer.
Okay.
The one who took advantage will be very happy and proud.
Yeah.
But those who made the mistake, maybe they can rationalize their mistake.
Okay. But the one sensible strategy is try and bid the price up while you're holding the asset and then hope to sell it at those high prices. But it's a risky strategy.
So in the theoretical exercise outside of the experiment, I mean, you can also solve your model in the presence of a bubble. And the bubble will actually increase at a given rate, which will be related to the discount factor. Did you try to see whether the rate of explosion of the price is equivalent to the inverse of the discount factor in your experiment?
It's related to what, sorry?
To the discount factor, to the inverse of your probability.
Well, the discount factor is fixed.
Yeah, but then that implies that when you solve forward your model, okay, in the presence of a bubble, the price will increase exactly at the same rate as the inverse of the discount factor. So then you could test to see whether you have a rational bubble or something which is totally irrational from the point of view of the effort.
Well, I understand what you're, but the discount factor doesn't change. The stopping probability. I mean, that is an interesting point. Some people may have thought this rolling die was fixed. And some people have thought, well, if it's rolled a long time and the 6 hasn't come up, it's going to come up soon. So they might say the probability to stop. Or the converse might apply. They say, okay, there's something biased about this.
But the fact that the discount factor doesn't change doesn't mean that the price cannot explode. So, in fact, if you solve a permanent income model with a rational bubble, you're going to have that the price of the asset will increase at the rate which will be 1 of the beta, where beta is a constant, which is the discount factor, to the t, and it will explode like this. I mean, you see it clearly when you solve
So even though beta is constant, you're saying it's rational for the price to go up.
It can be in the presence of a bubble. It can be so, yes.
Okay.
And then you can try to test that in your experiment.
Well, I'm still a little bit confused. I mean, the equilibrium price depends upon the discount rate, which is fixed. Okay, and you're saying somehow it can apply an equilibrium price increasing.
Yeah, because I buy a piece of paper from you because I think that I would be able to resell it.
Okay.
Okay. At what price would I be able to resell it?
Okay. So
and the interest rate in the equilibrium, if you impose that 1% times beta is equal to 1, that comes naturally from the earlier.
the bubble flowed at the rate of 1%. I'm a little bit lost because this hope surely is constant. I hope I'll be able to trade it tomorrow. Yeah. Okay. Well, I think that's probably
I think I have a paper almost 20 years ago that when you apply this kind of probability, end of the world discount factor, it's not perceived the same as a real discount factor. So I had the alternative was a string trade-off by 5/6 rather than this probability factor. And this attitude matters. So risk-averse subjects don't perceive 5/6 probability of going on for a period as a 5/6 discount factor, exactly.
Okay.
So some of your heterogeneity, I mean, it's this theorizing too much, but some of the heterogeneity might be because of people's heterogeneous risk attitudes, and therefore different perceptions of this constant 5/6.
But in equilibrium, the equilibrium is not stochastic. It's deterministic, so risk attitude doesn't affect the equilibrium.
No, not as long as you call 5/6 a discount factor.
Okay, but you say if it's a probability, but why should, if there's no risk at all in the equilibrium, why should they twist the probabilities? Why
Because
should
there
there be
is a risk
risk
of
of that?
not going on for one period, so
Okay.
there is a risk there, which is not in the original model, because the original model has a deterministic 5/6 rather than 5/6. We know people do fun things with probabilities. They distort them, they weight them, they do fun things, and so 5/6 probability is not the same as a theoretical 5/6 discount factor.
So what do you suggest we should have done?
I think one good thing would have been to check with an external elicitation procedure the risk attitudes of your subject, and try to see if a market, for example, this is a long shot, but it would be quite interesting, why the bubble market is more related to composition of specific risk attitudes, for example.
We didn't test for risk attitude, no. There were these weird demographic questions at the end.
But you could do in the future. So
Yeah.
I could do.
But this was time consuming and expensive.
I know.
Yeah. Okay, we did some, because of referees, we did some extra sessions. We did 2 of each, and we get exactly the same results. So that's it. Thank you very much for it. Thank you for your comments. I appreciate it.
Questions?
I'm wondering if the bubble does not come from the fact that those agents who have assets know the endowment of those that do not have assets.
Okay.
So if I know that you have only $1 to buy the asset, I will know that your maximum willing to pay is $1, and I will push probably the selling price from the beginning at $1.
Okay. I think we did one thing we checked, which perhaps is related to your question. We looked at the concentration of asset holdings. And we looked to see if the concentration of asset holdings affected the price, which it did. I don't have a slide to show you. But that's not the same. So if all the assets were held by one person.
So if I know that you have $1, and this is the first step.
Okay.
So, and I have the asset, I am tempted to establish a selling price very close to $1.
Yeah.
And in the next session, when you have the asset and you become a seller, you know, and it's obvious that you will try to sell for more than $1. So in this way, actually, you have an endowment that is fixed for everybody, but providing them the opportunity to trade in the second step and the third step, actually, you mechanically push the price up. Because if you bought at $1
Okay.
with all the money that you have in the first step, and the next step you become a seller and you are willing to have a profit, will drive up the price over $1.
If somebody accepts it. I mean, you could post a high bid or post a high ask, sorry, but it doesn't necessarily mean people will accept it.
Oh, probably I understood.
I want to ask
Misunderstood
a similar
that
question.
They did not have the same endowment.
No, they have different cash holdings every period. It oscillates from period to period.
In the first period,
No, the first period they have different endowments of cash, of tokens.
How the referee reacted to the bubble?
Sorry?
What did the referee ask you to do about the bubble?
They asked us to do more sessions.
And to show that the bubble was a one-time thing, or to try to see that the bubble is robust?
The referee wasn't really interested. They asked us to do more sessions. That's all. I mean, sometimes referees aren't very helpful, as we know. I don't know, I should tell you this now. This paper has just about a week ago been published in Management Science. And Management Science is not a bad journal, so we think that's a good signal.
Last question? No? Okay, thank you, John.
Thank you all.
Nice presentation. Sorry for being
Good job. But don't worry, your questions are very helpful. I mean, there's a lot we could do with the paper, but we haven't done it because the referees didn't want to. Because of price. Well, referees, I didn't ask us about the bubble. I did ask us to try and explain the bubble. Interesting. Well, thanks for your comment.
Yes. Did you also copy the link or just the PDF? The PDF. There was, they asked me when I downloaded the document, they asked me if I want a PDF or there is two types of formats. You can download
It's the URL there. I sent you a link, and the URL is also there.
the URL is not here, but I'll try to.
Because PowerPoint will be strange. I understand that on Windows system, PowerPoint wants to take control of the
Okay.
Microsoft wants to take control of everything and to make your life.
But
If it's PDF, they should not intervene.
okay, I will download the PDF
I'm sorry for the side comment.
Okay.
I don't understand the behavior of Microsoft. They see a PDF, they let the PDF reader take over.
Yeah.
And not propose the PowerPoint. PowerPoint is unnatural for a PDF. But it's Microsoft.
But we'll do this because I have to prepare the next session, which will start in a month. So it's not, but it's a copy.